All right, y'all, this is part 2 of lesson 4.3. We're still talking about ionization energy and periodic trends. And basically, what we're talking about here is what happens after a first electron is removed and a second one is going to be removed. So remember, we had aluminum. This is where we ended the last one. It had already lost one electron, so it's got a positive one charge because it has 13 protons and 12 electrons. Well, what happens when a second electron is removed? Okay, so then we have 13 protons and 11 electrons, which gives our aluminum a positive 2 charge. Well, what happens is even more energy is required to remove that second electron. It takes a little bit more. So the second ionization energy is the energy required to move the second electron after a first one has already been removed. So we've already lost one. We're on to losing the second. And the second ionization energy is even larger than the first. Let's go with higher. I don't like larger. It's a number. It's higher. Okay. Which means that we need more energy to take that electron away from a positively charged ion. So it's already got more protons than electrons. So this charge is already big. To try and remove another electron takes even more work. And as you might think, the third ionization energy is even higher than the second, and so on and so on. So it becomes harder and harder to remove an electron from a positive ion. Although, in each particular element, between one ionization energy, I need to start that over. Between one specific energy and the next, there is a very large increase. So you'll see a larger increase here than we did in our periodic table trend, right? Look at this large jump. It's 10 times as much. 6 times as much, right? Wow. So you can look here, 5, and it goes up a little, and then bam, there's a huge jump. So these very, very large jumps occur when you're down to the last electron, or the first electron from the next inner level, right? So like aluminum, come back up here. We've taken the 3 from the third shell. This fourth one, now we've come a little closer to the nucleus, and we're at a full shell of 8 electrons. So it's going to be really, really difficult to get that electron away. One, because it's closer to the nucleus, and 2, because it's a full shell that you're trying to break up. So you're trying to go from something super stable to not stable. So that requires a lot of energy. You know that's true for you too. It requires a lot more energy to get up off the couch and go do something than just to sit there, right? So to remove that first electron from a full shell is very, very difficult.